Okay, so I'm going to try and keep this video brief as I can. And all I'm trying to really do here is try and finish off your notes. I'm sorry I can't be here today, but I just wanted to make sure that you had your notes done so you could finish your homework packet and we could get those checked tomorrow. Okay, so the last objective for this unit is really talking about mixtures, their properties, analyzing them, and then trying to figure out what kind of separation techniques are best to use on different mixtures. Okay, so just to define mixtures to get it out of the way, a mixture is a combination of any two or more pure substances. And the thing about a mixture is it's it's different than a compound because a compound has elements that are bonded, okay, and they can't be separated physically. The thing about a mixture is just a combination of either elements and or elements in compounds, and they can be physically separated. There's no exchange of electrons here, so um, they're quite different. But again, but the way that they're the same is they are definitely a combination of either elements and elements, elements and compounds, or compounds and compounds. Okay. The other thing to really kind of keep in mind too is that in a mixture, each of the components actually keep their chemical properties. And as we talked about yesterday, that is not true with a compound. A compound, once they bond, once they exchange those electrons or share them, their properties change completely. Okay, and the compound kind of creates its own set of properties. That is not true with a mixture. All right, so types of mixtures. And we talked about those yesterday. A homogeneous mixture is something where the composition is consistent throughout. And again, I'm trying to encourage you not to think about this visually on a macroscopic scale, but rather try and think of it in terms of composition. Can I take multiple samples of this substance and those samples are all going to be consistent? Homogeneous mixtures are also called solutions, okay? And they don't have to necessarily be aqueous to be considered a solution. We can have a gas solution. We can have a solid solution. In fact, one of the most common solid solutions is called an alloy. And as we mentioned yesterday, all alloys are homogeneous mixtures. Brass, bronze, stainless steel, chrome, sterling silver, all of those alloys are consistent in their composition. Okay? Now, the heterogeneous mixture is where individual substances remain distinct. But again, try to not think about this visually, but rather if I'm taking samples of this same substance, okay, I'm going to get a different sample each time, okay? And so each of those different parts are definitely, well, they're distinct, but you're not going to get any kind of consistent composition throughout, okay? So a couple of examples might be sand and water, okay? Sand, anytime that you have sand mixed with water and you're taking those samples, more than likely each time you take that sample, you're not going to get the same amount of sand versus water in all of those. And then, of course, everybody thinks of the salad, because you have each of those parts distinct, you know, the crouton, the tomato, the piece of lettuce. And when you take samples of that salad, they're not going to be consistent. Okay, so I hope that kind of clears things up. Just because something looks homogeneous doesn't mean that it is. You really have to think of it in terms of consistency. Okay, all right, so once we have a mixture, how can we separate them? We have 5 different main separation techniques. And which one we use is really based on the type of mixture we have. Is it heterogeneous or is it homogeneous? Is it a liquid-liquid mixture? Things like that. So depending on what physical states we have that are mixed and the type of mixture it is how we kind of figure these out, which one we need the most of. The most common one is filtration. And this one, I'm sure you're probably familiar with it, uses a porous barrier, and it is always separating a solid from a liquid, okay? And these are used for heterogeneous mixtures. So a good example would have been our example from before, our sand and water mixture, which was heterogeneous. Solid being the sand and the water being the liquid, we can use a filter or a porous barrier to separate the two of them. Okay. Now the rest of the separation techniques really focus on homogeneous mixtures and their physical states. So distillation is very commonly used for two liquids in a mixture, in a homogeneous mixture specifically, and we separate things based on boiling points in distillation. So a good example might be a mixture of, say, alcohol and water. And if I wanted to separate this mixture, I wouldn't be able to filter one out. But what I could do is heat this mixture past the boiling point of the alcohol and yet below the boiling point of the water. So I would boil off the alcohol and capture that, and then leave the water behind, basically separating them. And again, this is for liquid-liquid mixture, homogeneous, okay? All right, crystallization is very similar, and to be honest, a lot of people get these two mixed up. But crystallization is a mixture of, it is for homogeneous, but it's for a solid and a liquid, okay? So if I have a liquid-liquid homogeneous, I'd use distillation. If I have a solid liquid mixture homogeneous, I would use crystallization. So a good example might be salt water. Salt water is a homogeneous mixture. And if I'm trying to separate the salt from the water, I would allow the water to evaporate. Now that might mean heating it up, but I'm going to allow that liquid to evaporate, and then it leaves the solid particles behind. Okay, so similar in that they use this idea of temperatures or evaporation to separate the two. But again, the big distinction is this: distillation is liquid-liquid and crystallization is solid-liquid. All right, and we have two more. One of them is called sublimation. Maybe you know what sublimation means, but just in case you didn't, if someone says something sublimates, that means we have a solid that is going directly to the gas phase. So it's skipping that liquid phase. So I'm heating up a solid up to its evaporation point. So sublimation is just like distillation, except that it's a solid-solid homogeneous mixture. Okay, so I'm going to take two solids, perhaps an alloy, and I'm going to separate it based on those boiling points or those evaporation points. I'm going to heat that alloy up past the boiling point of one metal, okay, and yet below the boiling point of the other metal, therefore evaporating one and leaving the other behind using sublimation, okay? So this one is different than distillation because it is using a solid homogeneous mixture. And finally, we have chromatography. Probably one of the few that you're probably pretty familiar with, because I'm guessing at some point, maybe in middle school, you did chromatography with maybe a black spot of black ink, okay? But chromatography is really based on this idea that different components of a mixture can be separated for their tendency or their attraction to other materials. So again, an idea or an example of this might be the separation of the black ink. You would have a dot of black ink on a piece of paper, and you would put it into a solvent of some kind, and the different components of the black ink, the different colors, would travel across that paper at different distances. Okay, so maybe the red component only goes so far, and then the blue component goes a different distance, and therefore separating those components. But keep in mind, chromatography is not just on paper. Lots of different components can be attracted to different things. There's column chromatography, lots of different types. So just keep in mind that paper example is definitely not the only one. And these are also used with homogeneous mixtures. Okay? All right. Well, I hope that made sense. And please let me know if you have any questions. So this is the end of this unit, which is good news. And so you have the rest of the class period to try and wrap up that homework packet. And I will see you tomorrow. And we'll get the key for the homework packet and make sure everybody is ready for the quiz on Monday. Okay? Great. Have a good afternoon.